Welcome to physics class. In today's class, we shall be studying about an activity in which a conductor placed in a magnetic field experiences a force. The conductor here we are using is named as AB. It is going to be suspended with the help of a stand with the help of the conducting wires, and it is placed in a magnetic field with the help of a horseshoe magnet. In this whole activity, we have to keep in our mind is we will be focusing on the direction of magnetic field, current, and the force that is going to be experienced by this conductor AB. So, in this whole activity, we will be discussing about the direction of magnetic field, current, and the force that is going to be experienced by the conductor. The direction of all these three parameters and the conclusion we get on changing the direction of magnetic field and current will be the conclusion of the activity. Suppose the question is asked for 3 or 4 marks. The diagram is compulsory. You will have to draw the diagram in the same way, in which the arrow mark in which the current flow will be shown is very important. In the first trial, the current is going to flow from positive terminal to the negative terminal. And the direction in which the current is going to flow through it is very clear here. It is flowing from B to A. This is how the direction of current will be there in the first trial. So, in the first trial, the direction of current is from B to A. Coming to the magnetic field. You can see the horseshoe magnet is suspended in such a way that we have the north pole here and south pole here, and there is always the force of attraction from north to the south. So, the magnetic field will be vertically upwards. That is from north to south. It will be in vertically upwards. I repeat. So, in the first trial, the convention flow of current is from positive to the negative terminal. So, the current flow will be from B to A through the conductor, which is suspended in a magnetic field. And the horseshoe magnet north pole is down and south pole is upwards. So, the direction of magnetic field is upwards. Keep one thing in mind, the magnetic force will always be from the north pole to the south pole. Hence, the magnetic field direction is upwards. Now, coming to the direction of force. What will be the direction of force that is going to be experienced by the conductor AB? In the first trial, when the current is flowing from B to A, the force will be acting on the conductor AB and it moves towards the left. It moves towards the left. According to Newton's law, there is an equal and opposite force that is going to be exerted here. As you all know that on passing current through a conductor, there will be a magnetic field generated around the conductor. Along with that, we have a magnet placed in its vicinity. So, both the forces come in contact and it exerts an equal and opposite force. Hence, the force that is going to act on the conductor AB, it will deflect to the left. So, we are going to observe the direction of magnetic field, current and the force. First, how is the direction of the magnetic field? It is from north to south. What about the current? It is from B to A, that is the direction. Now coming to the direction of force, it is going to move towards the left. Coming to the second trial. Now, in the second trial, we are going to interchange the positive and negative terminals of the battery. Hence, what happens? The direction of current also changes. So, it flows from positive to the negative terminal. What happens to the direction of current through the conductor? You can observe it flows from A to B. It flows from A to B. So, in the second trial, the current will be flowing from A to B. This is the direction of the current. It is from A to B. Let the magnetic field be in the same direction. We observe that the force experienced by the conductor will be in the right direction. It will be towards its right. Hence, on observing the direction of magnetic field, current and the force experienced by the conductor, keeping the direction of the magnetic field vertically upwards, changing the direction of the current, that is, it will be flowing from A to B, we observe that the force that is going to be exerted on the conductor, the equal and opposite force will be towards the right. So, we can conclude that in this experiment, on changing the direction of the current, we observe there is a change in the direction of force that is going to act on the conductor AB. So, we conclude that on changing the direction of current, there will also be change in the direction of force. Let me do one more trial by changing the north and south pole of the magnet, keeping the direction of the current same as B to A. In the previous trials, we had changed the direction of flow of current. Now we are changing the direction of the magnetic field. And we observe that the direction of force that is going to be experienced by the conductor will be to the right. So on changing the direction of magnetic field also, the force that is going to be experienced, it will be towards the right. Hence, we can conclude that by changing the direction of current or by changing the direction of magnetic field, the direction of force that is going to be experienced by the conductor will be changing. It is also observed that the force experienced by this conductor will be maximum when the conductor and the magnetic field are mutually perpendicular to each other. When the conductor and the magnetic field are mutually perpendicular to each other, the force is said to be maximum. This can also be proved with the help of Fleming's left-hand rule. Fleming's left-hand rule helps us to find the direction of magnetic field, current, and the force that is going to be experienced by the conductor. So, this is the complete explanation you will be writing when the question is asked for 3 or 4 marks. The deflection or the movement of the conductor towards the left or the right is an additional point I have added for you to understand it in a better way. According to your textbook, we will be focusing on magnetic field direction and current direction. In general, you can also mention that the direction of force experienced by the conductor AB changes on changing the direction of current and on changing the direction of magnetic field. Both the ways you can explain your activity. Hence, the force that is going to be experienced by the conductor will change its direction on changing the direction of current or magnetic field.